Thank you very much for attending this session, the sixth one in our list. This is recommendation engines. As usual, if you want to learn more about myself, this is an optional video. I strongly recommend that you attend the course structure and particularly what is a neural network. This video will be very useful for you to understand what it is. And then the environmental setup is another very important video where I explain how exactly you should set up the environment for doing the lab work. Okay, and then of course you can look at LMS and discussion forum, how to use our learning management systems. This is session 6 actually, not session 5. And unless you actually attended the last lecture or saw the video in the last lecture, this is not a good class to start. Okay, you should probably, if this is the first time you just came to this class, you might find yourself out of sync. Please feel free to stay, but wait for a week for the actual understanding starts, because only odd number sessions you can start. In the last class, we talked about how to actually build a recommendation engine. We said, hey, a recommendation matrix of any company like Amazon, like Netflix, or any book company looks like this. There is some set of users who are represented here by IDs, and there are some books here, again, which are represented by some IDs. And each user rated each ID, each book, some rating, right? 4, 3, none means he didn't read, or he read and he didn't rate, whatever that is. And obviously, most users wouldn't have, a user wouldn't have read most of the books. A book wouldn't have been read by most of the users. So many of the entries are none or zero, and such matrices are called sparse matrix. So a company like Netflix or Amazon, which is planning to start a recommendation engine, has material like this, which is a bunch of users, a bunch of items, and each cell value is the rating given by the user for that particular item. And none means the user didn't rate that particular item. Now, because there are many null values, this sparse matrix is a very inefficient way to actually store this information. There's a lot of matrix space that is wasted for storing the zero value. So what normally happens in the databases is the companies store the data this way. The first, the column is the ID of the user. The second column is the ID of the book or the item. The third column is the rating. So the second user probably rated all these books, whatever ratings he has given. Similarly, there's no rating given by the third user, but the fourth user again gave all these ratings. So this way, when you store it as these 3 different columns, obviously you are not wasting any space for none. You only store that user, that book combination for which you have a rating. So this is a much smaller data to store than your previous matrix. So most of the databases, people store it like this. Okay, good. Now that we know this is the matrix, but think of actually when I'm talking about the original data, think of that. There is books or users on the rows and books on the columns, and there's a large sparse matrix. And last class, we saw why it is important, and that it is very important and powerful to factorize matrices like numbers. So what we are going to do today is factorize these matrices. And we realize that when we factorize a user book matrix, we'll get user concept matrix and concept book matrix. And then we can find similarities between products and similarities between users.